Hello students, so today we will study chemical bonding and molecular structure, question part 3. Disclaimer, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. So basically what are we going to cover today is we are going to see some questions, okay, from 17 to 25 that will correspond to nine questions approximately, and let us see what those questions are. So starting from question number 17. Question number 17 says that the hybridization of nitrogen atom in NO3 minus, NO2 plus and NH4 plus respectively are, options are A sp2, B A sp2 sp3. Okay, then in B we have sp2 sp3, C sp3 sp2 and D sp2 sp3 sp. So you have 30 seconds to solve this question. Your time starts now. Now let us see how this can be solved. So first of all, what we have to do is we have to look for the hybridization of nitrogen atom in all these three nitrogen oxides and hydrides. Okay, so two oxides are there and one hydride is there. So first of all, the correct answer is B. So this is the explanation. So what we have to do is we have to count sigma bonds, lone pair and unshared electron pair. Okay, or count the number of atoms directly attached lone pair and shared pair electron to calculate hybridization. So what we can do, first thing we can do is we can count sigma bond, lone pair and unshared electron. Second thing we can do is we directly attached directly attached atom, lone pair and unshared pair. So they are the same thing in a way. So how can we now just do it for this species? So for this species, this for NO3 minus, this is the structure. NO2 plus, this is the structure, and NH4 plus, this is the structure. Okay, so we won't count this pi bonds, right? This pi bonds won't be counted. Only this sigma bond will be counted. Lone pair will be counted, and your surrounding atoms will be counted, or the bonded pair will be counted. So again here two pi bonds are extra, so we will not count this. And here all these three are pi sigma bond. So there are three sigma bond here, 1, 2, 3. Okay, and there is no lone pair. Therefore, what is the structure? So there are three bonds. So this will be sp2, sp1, p2. Here, what will be the structure? Again, no lone pair, sp, and here sp3. So this is the structure of all of this. Means sp2, sp, and sp3. Let us see the answer. The same thing written: sp2, sp, and sp3. Since there is no lone pair in each of this and no unpaired electron in each of this, only bond pairs are there, excluding the pi bond. Therefore, its structure is the first one and is having a structure of sp2, second one is having a structure of sp, and third one is having a structure of sp3, which is CH4 plus. Clear? Okay. Now moving on to the next question. Question number 18. Question number 18 says that the states of hybridization of boron and oxygen in boric acid H3BO3 are respectively, options are sp and sp3, A, B sp2 and sp3, C sp3 and sp2, D sp3 and sp. So you have 30 seconds to solve this question. Your time starts now. Okay, now let us see what is the solution. So first of all, what we have to do is we have to find the state of hybridization in H3BO3 and uh, uh in H3BO3 only of boron and oxygen both, right? So the correct option is B. First of all, this is the structure of H3BO3. Okay, this is the structure of H3BO3. Now boron has how many bonds? Where is it to count? 1, 2, 3. So it is sp2 hybridized. What about oxygen? So oxygen has 2 lone pairs and 2 bond pairs. So their total count is 4. Okay, we'll count in this way. Take a lone pair as 1 and a bond pair as 1. So 2 bond pair and 2 lone pair. So 1, 2, 3, 4. That is sp3 hybridized. So again, I am repeating it. In this H3BO3, that is your boric acid, your oxygen is sp3 hybridized and your boron is sp2 hybridized. Clear? Okay. Now moving on to the next question. Question number 19. Question number 19 says that we have to match the following and choose the correct option. Column 1, A SF4, B SF, IF5, C NO2 plus, D NH4 plus. And column 2, 1 sp3D, 2, 2 sp3, 3 sp, and 4 sp3D. So if you just apply code for each of this, so this is the code ABCD, then what is the correct option? So A is 4132, B is 1324, C is 3241, and D is 3124. So for A, A is this, B is this, C is this, and D is this. Okay, for each of this, if you consider A, in option A, your compound A, which is this, is having 4, which is sp3D. Okay, in this way it is distributed. So you have 30 seconds to solve this question. Your time starts now. Now let us see the solution. So the question says that we have different species, and you have to see that what is the hybridization of each of these species. So for SF4, I have 5 NO2 plus, and NH4 we have NH4 plus here, sp3D2, sp3, sp, and sp3D. So the correct option would be A. How will solve it? So for SF4, there are 4 bonds and 1 lone pair. So that contributes to 5. Therefore, 3 plus 2, 5, which is sp3D hybridization. Next is what? Next is IF5. There is 5 bond pair and 1 lone pair. So it is sp3D2, as there are total of 6. So 3 plus 2, and there is nothing. So 1, 5. Sorry, 6. Okay. Then we have NO2 plus. So 2 bond pair and no lone pair. So that is sp hybridization. Simple. 2, that is 1 for S and 1 for P. Clear? Now moving on to the next one. We have NH4 plus, where there is 4 bond pair and 0 lone pair again. So 4 bond pair means sp3 3, and this S has 1 here. That is total of 4. Now if you just try to match it, then SF4 will have sp3D, IF5 will have sp3D2, NO2 plus will have sp, and your NH4 plus will have sp3 hybridization. Okay. So keeping that in mind, we can write it. The structure also. The structure is also given. So this is SF5, trigonal bipyramidal. IF5. So this is the geometry. Okay, this is geometry, which is trigonal bipyramidal. Your IF5 has octahedral, NO2 has linear, and NH4 plus 4 plus has tetrahedral geometry. Okay, so this is for question number 19. Moving on to the next question. Question number 20. Question number 20 says that isostructural species are those which have the same shape and hybridization. Among the given species, identify the isostructural pairs. Options are A NF3 and BF3, B BF4 minus NH4 plus, C BCl3 and BrCl3, and D NH3 and NO3 minus. So you have 30 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. First of all, what we have to do? We have to look for isostructural species, means those species which have the same structure. Now, out of this pair, the correct answer is B, because the species BF4 minus and NH4 plus both have 4 bond pair and 0 lone pair. Therefore, the hybridization is sp3. Therefore, both of these species have similar shape and hybridization. That is, they are isostructural species. So this is their structure. It is clearly visible that both of them are adopting tetrahedral structure. So they both are isostructural. Clear? That is your BF4 minus and NH4 plus. Moving on to the next question. Question number 21. Question number 21 says that in which of the following pairs the two species are not isostructural? Options are A CO3 2 minus NO3 minus, B PCl4 plus and SiCl4, C PF5 and BRF5, and D ALF6 3 minus and SF6. So you have 30 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So first of all, we have to find that out of these species, three are isostructural. Means they out of these three, means two of them are having same structure. Okay, there are three such pairs. Now we have to find the fourth one which are not isostructural. So the correct answer is C. Why it is C? Because CO3 2 minus has and NO3 minus both are triangular planar. This is for the first one. Okay. For the second one, PCl4 plus and SiCl4 both are having tetrahedral. Okay. Now this C is having PF5 and BRF5. So P is pentavalent and BR is having a 7 valency. Right? It can contain up to 7 fluorine atoms. So therefore, it will left out one lone pair, which is not the case for PF5. Right? And as a result, PF5 will be triangular bipyramidal, which is steric hindrance 5. And if you calculate the steric hindrance for BRF5, it is 6. And therefore, its formula is, yes, its structure is square pyramidal and geometry is tetrahedral. Clear? So they are not isostructural, obvious. ALF6 3 minus and SF6 both are octahedral. Clear? Moving on to the next question. Okay, so before that, we have the structure also. This is for PF5 and this is for BRF5. You can see very clearly it is TBP and this is square pyramidal. Now question number 22. Question number 22 says that total number of lone pair of electrons on I3 minus is, options are A 3, B6, C9 and D2. You have 10 seconds to solve this, 30 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So first of all, what we have to do is we have to draw the structure of I3 minus and see what is the number of lone pair on this anion. The correct answer is C. So what is the structure of I3 minus? C here. So this is the structure of I3 minus, which is linear and having a geometry of trigonal bipyramidal. Now we have to count the number of lone pair of electrons and not the electrons. So don't answer it wrongly in this way. So 1, 2, 3, 4, 5 and 6. Similarly, 1, 2, 3. So 6 and 3, 9 total lone pairs are there. Clear? Okay. So the correct answer is what? The correct answer is 9. Okay. So as if you know the I3 minus structure, it is very easy and super easy to solve it. Clear? Okay. Now moving to the next question. Question number 23. Question number 23 says that in XZF2, XZF4 and XZF6, the number of lone pair on XZ respectively are, options are A 231, B 123, C 412 and D 321. So you have 30 seconds to solve this question. Your time starts now. Okay, now let us see a solution. First of all, what we have to do? We have to find the number of lone pair of electrons on Xz, that is the xenon in this xenon compound. So the correct answer is D. So how we can solve it? So first of all, xenon has 8 electrons in outermost shell. In case of XZF2, out of 8, 2 electrons are used, while 3 pairs are there. Okay. Now you can, in the case of XZF4, 4 electrons are involved, but still 4 are there to give the shape, sorry, geometry. Okay. Now next, question number 24. Question 24 says that the structure of IF7 is, options are square pyramidal, trigonal bipyramidal, octahedral and pentagonal bipyramidal. So you have 30 seconds to solve this question. Your time starts now. Okay. Now let us see how this can be solved. So what we have to find? We have to find the structure of IF7. The correct answer is D. So for that, we first of all consider the ground state electronic configuration of IF7. Iodine, and it is of course having 7 electrons in the say atom. So this will lead to this kind of configuration of the iodine in ground state: 1, 2, 3, 4, 5, 6, and 7. Right? That is in 5s2 and 5p5. Now next, we iodine, when it is excited, in the excited state, all of these orbitals are singly occupied. Okay, that would result in what? sp3d3 hybridization. Clear? Okay. Now keeping that in mind, we can write that sp3 hybridization is of which shape? Is of pentagonal bipyramidal. So this is very clear. This is your pentagon. Okay, this is your pentagon, and beneath and above this we have this fluorine, giving us what? IF5. Right. So this is octahedral, I would say. This is having how many arms? Sorry, corners: 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5. Okay, 5 are there. Okay. Now moving on to the next thing, which is that IF7 is pentagonal bipyramidal. Clear? Question number 25. Question 25 says that which has triangle bipyramidal shape? Your options are A XZO4, B XZO3, C XZO3F2, and D XZOF2. So you have 30 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. So what we have to see that out of all this, which one is having a TBP or a trigonal bipyramidal shape? The correct answer is C. How? Because XZO4 has total 8 electrons. Now 2 will be along with oxygen and 4 will be along with your fluorine. So 4 to 6. Okay, so 6, that is, yeah, so 6 electrons are involved. Therefore 5 bond pair and 1 lone pair. We are not considering 6 bond pair because pi bonds are not counted. Moving on to the next one, which is XZO3. So there are a total of 8 electrons. Out of this, 6 are involved with oxygen, and that will result in 3 bond pair excluding those covalent bond and 1 lone pair. So that will result in pyramidal shape. Next is XZO3F2. Again, 5 bond pair are there excluding your covalent bond and 0 lone pair, that is triangular bipyramidal shape. And of XZOF2, there are 3 bipyramidal and 2 lone pair, and hence it has T shape. Of course, 8 electrons are there, 2 are involved with fluorine, and rest of this involved with oxygen. So 2 to the 4. But since covalent bond are not counted, so 1 is excluded, and therefore 3 bond pair. Now the remaining 4 are involved in the lone pair, so that is total equal to 2 lone pair, and hence T shape is there. So this is the shape for your XZO3F2, and it is trigonal bipyramidal. Clear? Okay. So this was all for today's session. Thank you.